Each station has just 2 days takt time to complete its part of the production process. At Station 40, the 16-metre-long wings, which have reached the factory just in time, are attached to the fuselage. The first step for the engineers is to determine the exact position where the wings are to be attached.
There are several places where I have to ensure that there's no contact, so that no damage occurs between the wing and the fuselage. That's why I have to say stop from time to time. There might be contact. We need to go up a bit or a bit to the side.
With an accuracy of up to 0.4 millimeters, the wings are attached to the fuselage of the plane.
Once the wing has been installed onto the fuselage, our shop floor experts measure the position of the wing. We then go in with mirrors and other devices to make sure this wing is perfectly positioned onto the fuselage with no type of stress or gaps or anything else which we shouldn't have on this in this juncture. Once this has been performed, we are ready to rivet the wings onto the fuselage, and then we know that they are in the correct position and have no issues then further along the line.
20 centimeters, 10 centimeters, and we're in place.
More than half of all A320 family aircraft in the world are assembled in Finkenwerder. The front section of the fuselage is delivered from Saint-Nazaire. The engine pylons come from Toulouse, and from Hamburg, the tail section. The vertical stabilizers are made in Stade, while the flaps are sent from Bremen. The wings are assembled in Broughton in the UK. The horizontal stabilizers come from the Spanish city of Retafe. All in all, 7 different construction sites build and deliver the parts for final assembly. In the meantime, the engineers are checking the fittings.
To install the wing, we use so-called corner fittings. These are large sections of aluminium material which have form which is unique to each aircraft. They have a general form which arrives here in Hamburg, and each one is then measured and remeasured and fettled in order to have a perfect fit onto this aircraft. Once that's been performed, we can install this part onto the aircraft.
Team leader Dennis Tietjer monitors the installation of the pylons and engine mounts. This is an important milestone in the construction process, if there's to be any hope of staying on schedule.
How's it looking, lads?
Nearly done.
We're nearly finished here, so we'll be ready to mount in shift 4. Fantastic. Good work. See you later. Right now we're exactly halfway through the 6 shifts, the 48 hours that the aircraft spends in construction here. Now is exactly the moment when we can see whether we're on schedule. If we're ready to takt, which we are, then it means that construction's on schedule and that the assembly cycle is running smoothly.
In a different part of the site, the latest addition to the Airbus fleet, the A350, is being fitted out. Hall 261 is home to a large-scale assembly line. With 6 separate workstations, the roughly 13-metre-long sections of the plane's fuselage are fitted out up to a certain level of completion. Then, at predetermined intervals, or takts, each section moves up the assembly line. When a section is fully equipped, it leaves the hangar. Production manager Michael Witt leads a crew of 130 aircraft engineers working in a 2-shift system.
Here in Hamburg, in this hangar, we perform the system installation of the so-called forward section, which starts behind the cockpit and which ends in front of the wings, and the rear section, which starts behind the wing and ends at the rear end. System installation is the installation of mechanical systems like air conditioning pipes and electrical systems, so harnesses for data transfer.
The transport team brings a new empty section into the hall and puts it in position 1 in the assembly line. The engineers use a joystick to precisely maneuver the extremely heavy load into its resting place. When the sections arrive in the hangar, they are completely empty, except for any load-bearing structures. Inside the fuselage, the mechanics use a mirror ball to guide a finely calibrated laser beam to preset measuring points. A measuring instrument then determines whether the hull is perfectly straight.
So in A350 product we have very tight tolerances to have a very nice cabin at the end. For that we have a leveling of the section, of the fuselage section, to install the modules and at the end the cabin B brackets, that everything fits well in the major component assembly.
The fuselage must be completely straight, so that large
Lumen
components
Christi
can be correctly
TV,
installed.
truly Catholic.
The measuring process is repeated several times and then readjusted by another engineer one level further down.
Lumen Christi TV,
There we
truly
have
Catholic.
tolerances. First we have the leveling of the section and then we integrate the modules to specific attachment points which we
Lumen
measure on
Christi
top.
TV, truly Catholic.
The first large component is floating through the air, the so-called center module. It already contains a number of other key components, such as the plane's air
Lumen
conditioning.
Christi TV,
This
truly
module is
Catholic.
prefabricated at a separate assembly site and can now be pushed into the fuselage in one piece.
So specific for A350 is that we have the so-called
Lumen
modules
Christi TV,
underneath
truly
the upper
Catholic.
shell. Modules is an assembly of frames which we equip then with all the systems inside, so mechanical systems like air conditioning pipes
Lumen
and
Christi
electrical
TV,
harnesses. We
truly
do that
Catholic.
outside the section to have, during the ramp up, an opportunity to move the production line faster. So we have decoupled a big work package from the speed of the production line, and another advantage